Hello once again, this is Jeff Scott of Rankin Technical College with the final video in this series of videos I've been doing on Android AppInventor2. Now, there will be a total of 75, and I've actually got 74 done, but one is still being produced and a couple of them are still being uploaded to YouTube. But we started this adventure. I gave you a getting started and I wrote a few programs, the All-American program, The Boy Who Cried Wolf, Hello Kitty, Hello Doggy, two versions of a guessing game program. And then we got into the book. We went over Chapter 1, which was Hello Purr, Chapter 2, which was Paint Pot, Chapter 3, which was Mole Mash, Chapter 4, which was our No Texting While Driving app, Chapter 5, which was our Ladybug Chase, Chapter 6, our Paris Map Tour, Chapter 7, which is the Where Is My Car app, Chapter 8, our President's Quiz, Chapter 9, our Xylophone, Chapter 10, our Make Quiz, Take Quiz app, Chapter 11, our Broadcast Hub, after Chapter 11, I deviated away from the book and did a couple lectures, 2 or 3, on a Magic 8-Ball app. Chapter 12, which was our robot remote. Remember, again, that was very limited because I don't have access to a robot. Chapter 13, which was our Amazon bookstore. Now, most of those 13 chapters had 1, 2, 3, more than one lecture, maybe 3 to 5. But once we got into Chapter 14, and we were not talking anymore about apps, but about information regarding apps, we just did one lecture. So there's one lecture for Chapter 14, Understanding an App's Architecture, one for Chapter 15, Engineering and Debugging an App, one for Chapter 16, Programming Your App's Memory, one for Chapter 17, Creating Animated Apps, one for Chapter 18, Conditional Blocks, one for Chapter 19, Programming Lists of Data, one for Chapter 20, Repeating Blocks, and one for Chapter 21 on Procedures, one for Chapter 22 on Databases, one for Chapter 23 on Sensors, and we're going to get into the last lecture, Chapter 24 on Communicating with the Web. So let's walk our way into that one. As mentioned here, mobile technology is ubiquitous. And in other words, it's kind of all-encompassing. The web has changed the way that we live. All right, many people do much of their work online. Many people pay their bills online, do almost everything online. All right, as it says, mobile phones have moved well past just calling and texting. You have instant access to the world's data as well. You can use your phone's browser to reach the web, but often the small screen can make this problematic. Custom apps can provide a more attractive alternative to this. In this chapter, as mentioned, we take a look at App Inventor components that access web information. We learn how to show a web page. Remember, we had our web viewer component, which we've looked at before. We learn how to show a page within a user interface of the app. We learn about APIs and how to access information from a web service. Creativity, they mentioned there, is about mashing, and I've mentioned mashups before to you. It's quite often combining, for lack of better words, 2 or 3 different apps or 2 or 3 different websites to get related information. Websites and apps remix content from various data sources, and most sites are now designed with such interoperability in mind. And they give an example here. Just about every popular website now provides some kind of a machine-to-machine access type of alternative. As they say, this is a web service, and the protocol for how a client app should communicate is called the API, or Application Program Interface. Now, I want to mention something that I did a long time ago, but I just wanted to show it to you. And I'm going to come over here. Hopefully you don't consider this to be a waste of time. Oh, where is it? Insert. Shapes. All right. I want to quickly show you one of my first experiences with using web services. Well, let's just show it to you this way, okay? Years ago, I took a class that was on visualbasic.net. I was already teaching VB.net, but this was a class, an advanced class, to go over some stuff that I had never really talked about in class, because I knew what it was, but I hadn't done any examples or any work with it. So we built an app in that class that kind of looked like this. This right here, all right, was supposed to symbolize us keying something in on a screen. It could be a multi-line text box or something else, and so was this. This was a button and this was a button. This said English to Spanish, this said Spanish to English. So if I type something into the box here and clicked the English to Spanish button, then what would happen is in the other box over here, I would get the Spanish interpretation of whatever I typed in here. Or I could go the other way, type something in here in Spanish, click the button that said Spanish to English, and have it come in here. Now, it wasn't great. Sometimes the English to Spanish or the Spanish to English was a bit choppy or herky-jerky. Maybe it didn't exactly correspond, but it was pretty cool. Because what we were able to do was to use translator programs that weren't part of our program. We call them over the net. So in other words, we were using web services. Now they mention here that the Amazon Web Service is one of the first web services, as Amazon realized back in 2007 that it could be popular. All right. Notice what they talk about Facebook here too, and they say Facebook has kind of become a framework or a platform rather than a site, meaning that other languages can build onto and tap into Facebook's functionality. You may have seen this already where people set up user groups right on Facebook. Okay? So most websites, they mention here, offer both an API and a human interface. Thus, the web, it says, is one thing to us average humans. To programmers, it's the world's largest and most diverse database of information. The web viewer component that we looked at many videos ago lets you show a web page within an app. For instance, you can show Google Maps showing the user's current location. You can show Twitter. So if you wanted to be able to see recent topics, on something, you can use NBA.com for basketball stats on your favorite players, etc. The web viewer, which we'll look at in a second, is like the canvas components in that it defines a place on the screen. That's it right here. You can drag in a web viewer from the user interface drawer. Then you can dynamically change the way it appears by changing its height, by changing its width, etc. They've added 2 buttons here. There's a LeBron James button. I think that's a Steph Curry button. And as it says, if the user taps the picture of Stephen Curry, the app would show his page from NBA.com. All right, and the same with LeBron. So there would be Curry's, and LeBron's would be similar. Whereas Web Viewer displays a web page, the web component, which is a relatively new component in AppInventor, facilitates the app communicating with a web service using the Hypertext Transfer Protocol. Hopefully you've heard of HTTP, but the Hypertext Transfer Protocol, HTTP, involves you, the user, keying something into your address bar up here, and then hitting enter, which is sending a Hypertext Transfer Protocol or HTTP request. That request will be answered somewhere by some web server someplace, that will attempt to get whatever the user wants and send it back in the form of HTML. And that sending back is done in terms of an HTTP or a hypertext transfer protocol response. So it's HTTP is a request response type of architecture. In this chapter, the author mentions you'll be introduced to the web component through a relatively simple example that accesses financial stock price information from a public API made available by Yahoo Finance. The protocol for talking to this API is fairly simple, and the data returned is going to be not real pretty. Unfortunately, most APIs have complicated permission schemes and APIs, and they often return data in formats such as JSON, which is JavaScript Object Notation, or XML, which is the extensible markup language. That either one of those may require more advanced code. So the example that they show here down towards the bottom of this page, as it says, it's the blocks for an app that displays Google stock information when the app launches. So it's in the screen initialize. So we're telling it to go out, and we've got a web view or something here, and we're telling it to associate this URL with it and get it. And then we've got a got text, which is basically going to fill up something for us. So on screen.initialize, web1.url is set to the URL for communicating with Yahoo Finance. When the get is called, the request is made, but no data is returned immediately. Why? Because again, you're using TinyWebDB. So remember, it's a get followed by a got. So when Yahoo returns the requested data to the app, the got text event is triggered. This is where you can process the returned data. As mentioned here, the author says you can customize the web URL to get the information for a different company by just changing the address that's in there. TinyWebDB and TinyWebDB compliant APIs. It says here the web component provides a method for accessing APIs. If said API is fairly simple, you can use that component to directly access it. But other ones, such as Amazon's API, which we looked at in the Amazon app in Chapter 13, are more complicated. For complicated APIs, as mentioned here, an experienced programmer can set up a TinyWebDB compliant web service, their own web service. Once this has been set up, other programmers can access that web service with the tag value protocol. You send a particular tag as the parameter, and a list or text object is returned as the value. In this way, the AppInventor program is shielded from the difficult programming required to parse, which means break down into components, parse something into standard formats like XML or JSON. TinyWebDB compliant just means that a web service follows TinyWebDB's expected protocol. An example of this is the Amazon API that we used back in Chapter 13. In the past, the author mentions here, building APIs was difficult because you needed to understand programming, web protocols, you needed to set up a server to host the web service, etc. Now it's much easier because you can use cloud computing tools like Google's App Engine and Amazon's Elastic Compute Cloud to immediately deploy the service that you create. These platforms will not only host your web service, but they'll also let hundreds of users access it before they charge you any money for it. The details as mentioned are probably beyond the scope of this book, but if we go out here, we went out here before, but before when we did this, we were talking about doing something else with Python. All right, I think it was creating the web database. It was the one here. So that brings us to the end of our journey. As it says here, most websites and many mobile apps are not standalone entities. They do their jobs, they rely on interoperability of other sites. With AppInventor, you can build games, quizzes, etc., but soon enough you'll encounter issues related to web access. AppInventor provides 3 components that you can use to talk to the web. the web viewer for showing a live web page, the web component for accessing information from an API, and the TinyWeb DB component to access data in a specifically designed web API. And that pretty much, I believe, is it as far as what we have. All right, so that will be our 75th and last lecture. Wanted to put this up here. Again, I'm Jeff Scott. I'm an information technology instructor at Rankin Technical College in Wentzville, Missouri. And I can say here, formerly of, and that was Black Hawk Technical College, and that's in Janesville, Wisconsin. All right. My email address is jpscott@rankin.edu, so if any of you out there actually watch these videos and get something out of them and you want to give me a shout out, just send me an email or whatever, that'd be great. I also have my Rankin Technical College. This is my Android AppInventor2 YouTube channel. I'll leave that up there for just a second. But if you've got some interest, you can always go out just to youtube.com, go into the search box and type in Jeff Scott Rankin Technical College. And there's it says 75 videos, there's a lot more. All right, I have videos out there for AppInventor2, again the 75 C# programming, and there are currently 55 videos out there for that, and more are always coming. ASP.NET, which I've just started, there's not many videos out there, and there's actually more than that, but for some reason that's all that's showing. I also have 120 videos on HTML5, CSS3, JavaScript. And I'm eventually going to have more Java videos out here as well. All right, that's it. I hope you enjoyed this video series. And again, if you'd like, please feel free to send me an email, jpscott@rankin.edu. Until we meet again.